All right, tiling with algebra tiles. I know a lot of you don't like tiling because you have to really think about what you're doing. I'm not saying that you're lazy. I am saying that sometimes we don't want to think, and I cannot say I blame you for that. But tiling really requires you to think about what you're going to do. Tiling is also useful because it allows you to manipulate, actually using the tiles allows you to manipulate, really understand how you're changing the X values to make them fit. So when we tile, the tiling box they give you is kind of more like, looks more like that, and your product is in here. I'm going to start off by giving you a box that looks like this. So when you actually tile, here's what I want you to always be thinking about. Your X squared tiles are always going to go in this box, and your ones are always going to go down here in this box. When you're going to have X's in both of these boxes, and the X's that are in this box are always going to be vertical, and the X's in this box always have to be horizontal. Now, the X box, the boxes, the colors in here, so these, if one of them is positive, they've all got to be positive. If one of them is positive, they've all got to be positive. So, but I can have positives here and negatives there. But whatever's over here, they all have to be the same, and whatever's over here, they all have to be the same. But these don't have to be the same as each other. When I get done making my tile, it's going to look like a square. So if I smush all of my tiles together, they're going to make a square. All right? So let's take a look at this one right here, x squared plus 4x plus 4. Okay? I'm going to do the actual tile box so that we can actually write down what we get when we're done. Okay, so I have to start by putting my x squared, and again, if we want to, let's just make a little, kind of a little dotted line here so we can kind of see those areas, because we have to have our squares here and our ones here. So it's x squared, and I have to have positive 4 here. Now, I cannot flip these. I can rearrange the x squared and the 4. So instead of being 1 times 4, I can make it 4 times 1. I can make it 2 times 2. But I can't flip these. If these are positive, they got to stay positive. If this is positive, it's got to stay positive. If they're negative, they can't change sign. But I can rearrange them so that they look, you know, so that I have different possibilities of what I can put for my x's. Okay? So let's just say that I put these tiles here down like this. Okay? I need to figure out how I'm going to lay down 4 x's. Okay, so I'm just going to get 4 positive x's and see what I can make happen. Okay, well, if I put 4 x's here, hey, that works. But if I smush these all together, they're not a rectangle because I got this piece missing here. So this cannot be the way I want them to go because they don't fit. Okay, so let's try. I mean, and if I do 1 times 4, it's going to be the same way. I'm going to have 4 over here. They'll be just horizontal, and I'll still have a missing piece. Okay? Let's try 2 by 2. If I do a 2 by 2, so when I say I have to move them around, what I mean by that is if I have 2 rows of 1 tiles, I have to have that many rows over here. If I have 2 columns of 1 tiles, I have to have that many columns of x tiles as well. So I hope that kind of makes sense. Now when I look at this, I have x squared, 1, 2, 3, 4x plus 4, which is exactly what I wanted to get. So now I'm going to figure out what my factors are. I'm going to cover this up, and I'm going to look at, so this looks like an x, a positive x, and that looks like 2 positive 1s. Okay? When I go here, this looks like an x and 2 positive 1s. Okay? For my final answer that I actually tile myself, I'm not going to just I'm going to actually draw those tiles. X squared, 1, 2. These are my horizontal tiles. And then I have 1, 2, 3, 4. So what does this mean? What this means is that x squared plus 4x plus 4 equals x plus 2 times x plus 2, which is x plus 2 squared. Either one of these answers is going to be the same thing. Okay, so that one was kind of easy, and that was not a complicated one. Okay, but it followed the rules. Again, the rules are we have to have our x's up here, our 1's down here. We have to have same sign in both places. These are horizontal. I mean, these are vertical. These are horizontal. Okay, so let's try one that's a little harder, okay? The next one we're going to try is 2x squared plus 9x plus 4. We're going to figure out what that's equal to, okay? So again, I'm going to make my little T here, and then I'm just going to kind of do a little dashed line there to help me. I'm going to, okay, well, obviously I did not make my dashed line big enough. There's my dashed area now. Let's kind of scoop this. We'll make this bigger, okay? All right, now you can kind of see it. That's better enough. Okay, good. All right, so now I've got 2x squareds. And then down here I have, I just forgot this, I've got my positive 4. And again, I can rearrange these 2x, these 2x squareds and this positive 4, but I can't flip them, okay? So I'm just going to start off like this, okay? I'm going to put, I've got 4, so I've got to have 4 columns of x's right here. And then I've got 1 row, so I have to have a whole row of x's here, okay? It's a square, well, it's a rectangle, and I don't have any holes, and I've got all the same signs here, and I didn't flip these, so it looks good. Problem is I have 2x squared plus 1, 2, 3, 4, 5, 6x. I don't want 6x, I want 9x. So this is obviously not right, okay? So that's not going to work. So let's try, instead of doing 1 times 4, let's try 2 times 2 and see if that gets us where we want to go. Okay, so now I took these away because I only had 2 columns, and now I've got to have 2 rows. Well, that actually didn't do anything. I'm still 2x squared plus 6x plus 4. So let's try, instead of 1 times 4, let's try 4 times 1. Okay, so now I only need 1 column here, but I need 4 rows. So let's keep on adding. There's 3 rows. Now here's 4 rows. Okay, well, look at that. Now I've got 2x squared, 1, 2, 3, 4, 5, 6, 7, 8, plus 9x plus 4. And that's what I wanted to see. So again, we would draw these tiles in, and then I have 2x plus 1 here. I have 1x plus 4 here, so it's 2x plus 1 times x plus 4. All right, now let's talk a little bit about how we can tell whether I need to have 1 sign or 2 signs. Okay, so whenever let's look at 2 different expressions. Okay, so let's look at this one. Let's look at x squared minus 7x plus 10, and let's look at 3x squared minus 2x minus 5. Okay, I'm going to decide whether I need opposite signs on my x's, so whether I need to have some reds and some greens. I'm going to look at C. C is going to tell me whether or not I need opposite signs. Well, C is the constant, okay? And we'll talk more about standard form tomorrow. Okay, if this is positive, there's only 2 ways to get a positive. I can do positive times a positive or negative times a negative, okay? To get a negative, I have to have opposite signs, okay? So when C is negative, that means when I set up my tiling box, okay, I'm going to have some positives in one place and some negatives in the other one. That's what it always means, okay? Now, when I have this, when I have a positive C, I look here at this one, at B, to decide whether or not I'm going to do positive, positive, or negative, negative. If this is negative and this is positive, then these have to both be negative, okay? If this was x squared plus 7x plus 10, then I would have both of them would be positive. Okay, let me show you what that means. Okay, so that was a lot of positive and negative and maybe very confusing, but let's see what happens. Okay, so let's try this one, over here, this 3x squared minus 2x minus 5. Okay, so I see I have a negative, that this is negative. That means my x's will be positive and negative. I'm going to have both positive and negative. Okay, so I have to have, let's draw my little thingy here. I have to have 3x squareds, and I have to have 5 negatives. 3, 4, 5. Okay, so I have to have 3x squareds and 5 negatives. Now, I'll be honest with you, I can already tell just by looking at this that I don't want them to go this way, because I'm going to have 5 rows of negative 3. That's already negative 15, and I'm only going to have one column with 1 positive. That's going to get me negative 14. That's way more than I want. So I can kind of already tell that they have to be laid out like this. Okay? So now I'm going to look at this. So I'm going to try putting down tiles. I have negative 2. So that means I need to have more negatives than I have positives. Here I've got space for, I'm going to have 1, 2, 3, 4, 5 columns, and here I'm going to have 1, 2, 3 rows. That means my negatives have to go here because I have to have more negatives than positives. You may be asking, but why do I have to have more negatives than positives? Because when I actually get this tiled, I have, if I actually just write down what I see, I have 3x squared minus 5x plus 3x minus 5. When I combine these, I get 3x squared minus 2x minus 5. Okay? These are 0 pairs. Remember, a positive and a negative cancel out, leaving me negative 3x squared minus 2x minus 5. They're part of our answer, though, so when we draw our final answer, we're going to keep them tiled. But the reason they're there is because they're part of this answer down here. Okay, so when I actually write down my answer, I'm going to have x plus 1, 3x minus 5. Okay, so that means this equals x plus 1, these are minuses, these are minuses, just color those in, and 3x minus 5. Okay, we will talk about this more tomorrow. Don't worry too much about it. I want you to what I wanted you to do today was I really wanted you to think about how you would have to rearrange this stuff to give you the x values that you want. And we're going to build on that tomorrow when we do the box and diamond method. All right, don't worry about it. Everything's going to be good.